Okay, thank you, and hello from my side. Thank you, Esther, for your introduction, and thank you also to the other track organizers especially from Lucerne University, for inviting me to talk here. I want to talk to you how we at geoimpact apply machine learning for boosting the energy transition. Okay, so we at geoimpact have a vision which is also a common goal of our society, namely a sustainable energy system. And this energy transitions requires us to go from several mostly centralized energy systems today to one single, more interconnected and also more decentralized system in the future. So for example, in this future system, there will be over 2 million buildings that are becoming prosumers, and over 5 million cars will become movable storages. Over, I don't know how many million devices will become load balancing tools that should help to stabilize the electricity system. And as we see, almost everybody will be involved somehow in the process of the energy transition. And so as a consequence, also the decisions that shape this future energy system will be taken every day and everywhere. So this brings us to the question how to implement such a complex system. And our approach at geoimpact is to connect data, AI, and people. This is also the idea of our main product, which is called Swiss Energy Planning. And Swiss Energy Planning is a platform where we collect and join energy-related data. We uncover the energy potential of every building in Switzerland. We support the planning phase, for example, with energy simulation and other tools. And we connect the stakeholders of the energy transition, which are the building owners, the utilities, the municipalities, product sellers, and so on. And of course, what we are most interested in today, we also use machine learning in Swiss Energy Planning. We use machine learning kind of two types of use cases. The one type is more data-oriented, which is things like data enhancement and analysis insights. And the other types are more process-oriented, for example, a lead generator or increasing user experience and so on. And what I would also like to mention at this point, as often people like to ask us where we get our data from, is this open government data strategy of Switzerland, where there have been many improvements just in the very recent past. So about half a year ago, the Register of Buildings and Dwellings improved their API access, and just about a month ago, Swiss Topo proudly announced their new open government data strategy. And even more recently, this month, a new data set about electricity production was published, containing all electricity production systems, including PV systems in Switzerland. So here are the links if you're interested in this. And of course, this open government data bring a lot of opportunities for the energy transition, but also for machine learning practitioners and researchers in general. And just as a small note, when we started about 3 to 4 years ago with our project, having the data was already a key asset. But now with data becoming more and more available, we can focus more and more on the essential part, which are our use cases. So now I want to present you 3 use cases. And the first one is about metrics. So first, design and implement metrics. This is not only my advice, but it's also rule number 2 of Google's rules of machine learning. So also just a month ago, we published our new application, which is called Energy Reporter, where we monitor metrics for the energy transition. And here so far we publish the share of electric cars, the usage of PV potential, and the share of renewable heatings for every municipality in Switzerland. Yeah, and when we started with this application, a big question was which metrics we should choose to monitor the energy transition. And here I found another rule from Google, which says that choose a simple, observable, and attributable metric for your first objective. And actually, we came up with pretty similar criteria. The first one was understandability. So as I already mentioned, almost everybody is somehow involved in this process of the energy transition. So it's good if also everybody is able to understand our metrics. And this means, for example, if somebody buys a new car, then he can say if he buys an electric car, then this car metric will increase, and if he buys a fossil car, then it will decrease. And it was also important to publish the metrics on municipality level, so because people like to identify with their municipality. And yeah, the second criteria was data availability, or at least the data should be somehow observable. Sometimes it maybe has to be made available first, but yeah, it shouldn't be too complex to do that. And the third point is comparability. The idea here is that we humans can assess raw numbers best if we are able to compare different examples. So that is another reason why it was important for us to publish the values for each municipality and not just single values for Switzerland, so that we receive some interactive app where people can compare their municipalities to others and so on. And with this, comparability generates probably even some sort of optimization when these metrics become objective, when the municipalities compare to their neighbors and say, maybe here we can improve and so on. But now I want to also show some other ways we use to even more increase those metrics or support the energy transition. So one use case here is the renovation pressure. So the renovation pressure of a building is the probability that the building would have already been renovated today. And we calculate this based on properties of the building. So you can formulate this as such an integral where Ri is the renovation pressure of building I, Yi is the renovation age, which is the time since the last renovation. This expression in the integral is the conditional density of the renovation age given the building. You could also think of this as a renovation characteristic of the building. And this is an output of a machine learning model. And the input of the machine learning model is Xi, which are the features of the building. And on the right-hand side, you see this plot of two renovation characteristics of two different buildings. So building 0 with the blue curve has a renovation period, most likely around 10 years, and building 1 has a renovation period about around 25 years. And the actual renovation age of building 0 is 15 years, and the one of building 1 is 25 years, even though they almost get to the same value of renovation pressure, which is R0 and R1. What you see from this is that the renovation pressure does not only depend on the renovation age, but also on the renovation characteristic of a certain building. And now use cases where this renovation pressure is already used by our customers is by municipalities and product sellers, and they like to inform the building owners about their energy strategy or about their product at the right time, ideally before the building has been renovated. And it's also used by urban and real estate developers to find buildings with high development potential. And we further use it as a feature for training other machine learning algorithms. And you could also think of similar applications along this idea. For example, a heating replacement pressure. And we are actually in an ongoing project with University of Lucerne about this topic. Yeah, and another use case is the machine learning leads generator. The idea here is to find promising future customers given a list of past sales of your product. Yeah, and for this, we train a machine learning model that distinguishes sales, so building with sales, from average buildings. And on the right-hand side, you can see a partial dependence plot of such a trained model. So for example, feature 5 here in the middle is actually just the renovation pressure I just introduced before. So what you see here is that for low renovation pressure, the probability for sale was higher, and for high renovation pressure, the probability was lower in this example. Yeah, this is a joint optimization and learning problem, which means that there is some sort of exploitation trade-off in it. If you choose always the optimal proposed building from your model, you probably end up contacting customers which are really similar to the ones you already know. And with this, you probably miss out another group of customers you don't know, but which could also be promising. And to handle this, you should introduce some sort of randomization into this process. And one algorithm that is doing that is Thompson sampling. Yeah. We have applied this lead generator to a sales campaign for a PV seller, and we have generated 200 leads and contacted the customers. From these, actually, 19 were actively interested in building a PV system. And this conversion rate of almost 10% was much larger than the 1% benchmark we were defining in advance for assessing the quality. You could think of this lead generator as a complementary marketing strategy. For example, with Google Ads, you get many leads of possible low quality, whereas with this lead generator, of course, you have to contact the customers actively, but you can find your preferred customers, and you can also target customers which are not likely to react to an online campaign. Yeah, with this, I'm coming to an end. We have other ongoing machine learning use cases in our pipeline. One is the heating, prediction of heating system, which is an ongoing project together with University of Lucerne again. And here we already have promising results of an accuracy of 88% for predicting fossil heatings. This I already mentioned. We have an energy demand estimation project with University of Lucerne. And yeah, here are some further use cases. If you are interested in any of these use cases or have other questions, I would be happy if you contact me. So here's my contact. And with this, I'd like to end, and I'm curious about your questions.
Great. Thank you, Thilo, for this very nice and interesting talk. I would like to note, please don't be shy. I'm checking the Q&A currently. I think the moment is the question left from the last talk. So I will start with one. I was wondering if you could elaborate or explain a little bit more about how you or where you get your data, which sources you use to collect the data you need, or if you do this usually always together with your customer. If you could elaborate on this a little bit.
Yeah, so the idea is actually that most of the data we already have aggregated, and when the customer comes, that we already can implement the use case so that there is no aggregation phase. And yeah, so sources, I already mentioned 3, which is the Register of Buildings and Dwellings, Swiss Topo, which has many data. And yeah, we also have data partners where we share our data with them and they share their data with us. But yeah, most of it is actually publicly accessible data. But of course, to bring it together is also one of our tasks. It needs some effort, which we have already done. Yeah.
Yeah, great. And maybe a small follow-up. Is there some data at the moment that you would like to have, but that is not available due to some data policy or some other issues?
So one I wanted to have, and just we got published this month, is what I mentioned, was the PV plants. That's pretty cool, I think. Mm-hmm. And what I would like to have, what we always hear from our customers is the building owners. Yeah.
Okay, yeah.
Yeah. But for me, yeah.
Great. Then I have a bit of wider question. I was wondering about, like, if I try to zoom out a bit and look over the whole of Switzerland and the energy transition, like following your opinion or all the experience you already have in the field, what do you think would be the next big important step to enable energy transition in Switzerland? Like maybe you have some ideas on kind of data policy in general, or what do you think should be needed or be done from a political side? Maybe you can give your ideas or thoughts.
I haven't just concretely thought about that right now. Yeah, I mean, one thing that would, of course, be interesting is more on the data part, is even more, so to continue with this open data strategy, probably also with some sort of public data hub, because probably some data cannot be made open, but if there would be one single organization that would organize the sharing of such data, this would also be very interesting. I mean, we are in some talks with this and some thoughts about this, but this is very in the beginning of, yeah.
Yeah, great. Thank you. I was just wondering about your opinion. I'm afraid we are already at the end of our Q&A. Oh, actually, there is one quick question. Maybe we can have a minute. Braulio Barahona, he asks if you could elaborate on the energy reporter tool and if it can also be used by individuals to input their own data.
I'm not sure about which reporting tool is referenced. Do you know that?
I think it was on your slide, unfortunately.
So the energy reporter.
Yeah, exactly.
For individuals. So we just update the data as like monthly or as often as we have it. So the individuals, they don't have to submit anything. But,
okay.
But I'm not sure if I understand.
I think yes. It seems he was happy with your answer. He just wrote in the Q&A. Thank you.